Right, welcome to Dr. Carp Society Mission. So we are on physics, okay, and this is the English version. Right. So the first topic that we're going to treat will be centered on motion. Centered on motion. Right. So when we talk about motion, of course, we are talking about changing your position or location to another point. So this will be linear, this will be circular. So the whole thing. Let me put it this way. Like that. Let's see, like this. Center. This is one. Okay. This is the object. It's moving. This is center. So this is the rotating. Okay. Then we can have a wave which will be going up and down like that. Okay. So basically these are the types of motion we'll be looking at. And we'll look at how we can derive the equations for all of them. So that when we are given problems, we'll be able to answer the problems. So this is linear motion. From the word linear, it means line, straight line, more or less a straight line. So linear motion, motion that goes in a straight line, okay, or more or less a straight line kind of motion. So that's linear motion. Of course, under motion, we are still talking, it's also another word, dynamics, okay, right, or kinetics and so on. So linear motion, of course, because this one is going round, it's going on like that, okay, this will describe what we call the circular motion. Let me add to this one. Let's assume that this is the spring. Okay, the load is attached to it. And then we can also have the pendulum. Okay, which is swinging like that. Okay, so you have that, then you have that. So this is a circular motion. Now this is rotational. Rotational. So the whole body is continuous to the fixed point, and it is moving. It's rotating. Okay, but the body is in the circle. There's a circle, it's in the circle, and it's going on. Okay, so this can describe motions like revolution, and so a body going around, revolving, going around object. Okay, and this is rotational, it's rotating. So it has a fixed point on it, part of the body. It's in the fixed point and it's going around. That is rotational, right? Okay. So then beyond that, we come to this to and fro movement. To and fro movement. Okay. So this, like the wave, the sea wave goes up and come down, goes up and come down. Okay. If you have a spring, and then you attach load to it, you pull it down to go up and come down, go up and come down, go up and come down. So this to and fro movement is what we call simple harmonic motion. Right, so that is that. So basically, we'll be looking at these kind of motions, okay? We'll be looking at these kind of motions. So you see that here, for linear motion, maybe you are here, the body is here. It starts with initial motion u, then it starts moving. As it's moving, it's changing its velocity. by an acceleration. So when a body is changing its velocity, we call that acceleration. So it is accelerating by a, and then until it gets to its final velocity, the final velocity v. Okay, same thing. So as in the circular motion, you have part of it. This part of it is more or less like linear motion. Okay, but because it's moving, circular motion. Anything moving will definitely have this. It will be changing its angles. It will be changing its angles. So as part of it, yeah. So as part of it, it's going to have the kind of the circular motion with acceleration, angular acceleration. So in terms of distance, so this is distance changing, that is the linear aspect, proportional to the linear. The angles will be changing, and that will be giving us what we call the angular aspect. Okay, so this is going on like that. So this will also have a similar kind of analysis. Okay, the angles will be changing. Apart from distance changing here, angles will be changing. So this S will be proportional to the linear part of the motion, and this will be part to the angle part, which is the angular motion, angle change. Okay. Of course, these ones will be having the same thing. Assuming this is the part that gets to the lowest part. As it goes like that, it comes back. It goes and comes back. It goes and comes. So this also, it goes up, comes down in the opposite direction, goes up, comes down in the opposite direction. Okay. Right. So if you have this y and this x, it has displacement along the. It has displacement which is the same as distance. Okay. It goes up. It changes distance in the y, and then changes distance in the x-axis too. But usually, instead of x distance, we are plotting it against t. So time. So as time is changing, its velocity, its distance from a fixed point along the y will be changing. So it goes up as it's going. It will be having changing in y until it gets to the maximum point. Then it starts coming down. So it's becoming negative until it gets to 0, and then goes in the opposite direction. Okay, so that will be simple harmonic equation. Right. So you can always look at the movement along this one. This movement from here to here, it's more or less, if we were to bring this together like this, then this is it's similar to what? It's similar to circular motion. Okay. So we can describe it as such. So basically this is what we should note. So we should note in linear motion we have that initial motion u, and then you are moving through a acceleration, and this is your distance s. Distance with respect to, so s with respect to direction. Distance, when we consider direction, is what we call displacement. It's called displacement. It's called displacement, right? So basically, these are the types of motions that we have that will be given with. So at the back of your mind, you should have this. Is the body is moving, so the distance, there's a change in distance. It's actually changing distance. As it's changing distance, we can also look at an angle from a fixed point like that. If we look at it as a starting point, as it's changing distance, it's changing angle, and that is the angular. So at this point, it's like 90 degrees. Then beyond this point, it's increasing. So at this point, it's 180 degrees. It goes like that. Okay, so that's angular. So we have the angular portion. We have the linear motion, and then these will have their velocities, you have their accelerations. Okay, these angles will also have their angular velocity. It will have angular acceleration. Okay, so these you can describe it as initial angular velocity, final angular velocity, and so on. So let's start with the linear equation, the linear motion. So, like we said, let me just add something small to this. It is the pendulum. Pendulum is when you have a thread or a string, or a suture or a thread, okay, and then at the end we have, let's say, a ball, a metallic ball, okay. When you swing it like that, it moves moves with a certain, let's say you displace it to the left with a small angle, it will move like that, keep on moving. Okay, okay, to keep on moving. Right. Now the time that it will take to move and come back can be calculated as t, because if it goes and comes back, it's like it has completed a circle. So that will be the time taken to complete the time taken to complete a circular motion. That is what we call, that time is a special time we call the period, the period of the motion. Okay, that t. Okay, that t we will try and relate it to the length and then gravity. Okay, this is the length of the thread. Okay, so then this will also be a body here that we have. This string will have a certain property we can call k. Certain property called k. And we can displace it by distance r, so distance x here, and then this distance is what it will be changing with. Okay, and we can find a relationship between the force that it is using to move down and up. Right. So let's move on to linear motion. So we are here, linear motion. So we have let's say, this box here, and then we are pulling it to distance here. So this is the force pulling it, this is the body. And let's say we start pulling it with F. That's force, okay? Start pulling it with an initial velocity of u. Now, as we are moving it, we are making it change its velocity. So it's changing its velocity, okay? Velocity, of course, we should define that. What is velocity? Velocity is proportional to speed, okay? But we'll look at something. Speed, how fast you are moving, which is expressed by the distance you have traveled divided by time, okay? Speed is a scalar quantity. When you say scalar quantity, it means we are not looking at the direction. It just has size or magnitude, okay? But no magnitude, okay? But no what? Direction, okay? This velocity has both size and direction. So we say it is called vector quantity. So it's a vector quantity, but they have the same expression. So in actual sense, velocity will be equal to displacement, because it has a direction. Displacement is also distance in a particular direction. So distance with direction is displacement. Displacement over time is velocity. Whilst the speed will be what? Distance over time. Right. Now let's look at what happens here. Let's assume this is our initial velocity. That is the distance that we travel. The distance that we travel in t, the time t. So the distance, the velocity that we are starting with is u. Now we will need the force to move us. So if the force is moving and it's changing u, maybe at this point it has changed u to v. The rate at which it was able to change u to v is what we call acceleration. It's what we call acceleration. Okay. So it is this force. The force here is pulling this. It's moving it. It's moving it and changing the velocity from u to v. The change in the velocity. How the force was able to change u to v. That change is what we call acceleration. Okay. So if I'm moving and I'm changing my velocity very fast, it means I'm accelerating a lot. And sometimes you may be moving very fast, and then you want to reduce your speed. As you are reducing your speed, if you are reducing your speed, we say you are decelerating. Decelerating. If you are increasing your speed, it is accelerating. So we start with U, and then we are moving to the distance here. Let's say point A to B, which is distance S. By the time we get to B, our velocity is V. Right? So let's look at some calculations or some formulas that we can derive. Let's look at one. What will velocity be? Velocity, we have said, is distance over time. Okay, so what distance we have moved? We have moved S, and our time would have been T final, T initial. That is the time. The final, if you study from 0 to n. So this will reduce to what? S over T. That is your V. Okay, your velocity. Now, sometimes, because we started with U and B, which one is going to be our what do you call it? Velocity? We would have to find what? Of course, we have to find the average velocity. So if you want to find the average, we have U and V as velocities. So if you want to find a velocity that should stand for the two, we should find the average. So average velocity will be equal to U plus V. When you are finding average, you add the two, divide by the number of elements there. So number of elements, you have 2, so divided by 2, which is the same as half U plus V. Alright, so we'll come to that. Now, let's move a little beyond that. Now let's come to, by definition, acceleration. So this is linear acceleration. So linear acceleration. So linear acceleration, we said, is change in velocity. Change in velocity. Change usually, or the rate at which velocity is changing. Rate of change of velocity. Rate of change of velocity. Once we say rate, then it means we are looking at it with respect to time. So linear acceleration, which we will denote by A, will be equal to what? Change in velocity over time. Okay, anytime we are looking at change, we said change is what? Your final velocity. Your final change is always final over initial. So our final velocity here, when we move from U to V, when we move from U to V, it was final velocity was V. The initial velocity minus the initial velocity, which is U, over time, which is T. So this is the first equation we want to look at. Right. Now let's look at the second equation. You know, the distance that you have moved, let's say distance is S. This distance that you have moved, you want to find this distance. It will be velocity, your speed. Your velocity times what? Time. From here, we said velocity is equal to distance over time. So this implies that S here, if we bring T here, it is divided, so it will be equal to what? Velocity times T. And that's what is written here. Distance is equal to velocity times T. But remember here, what are the velocities that we have? We have initial velocity and final velocity. So which one are you going to multiply by? Time. That means we have to use average of this. And we said the average velocity, to find average is what? The 2, you sum the 2. So 2 half plus V over 2 times T. So this is another equation I want you to keep. Right. So when we have these two, we can derive the other equations of motion with ease. Okay. Right, so let's go. So we have said A is equal to V minus U over T. We have said S is equal to U plus V over 2 times T. Okay, now let's try and do substitution. Let's assume that we want to have an equation that will contain U, V, and then let's say T, or another one with acceleration in it. So let's see how we can go, or maybe for one equation that maybe we have only U in it. So what's happening is you can make so many substitutions, okay? So you can have an equation like, you can have a journey like this. Maybe initial velocity is, you are giving initial velocity, you are giving acceleration, and then you are giving time, and then you are giving distance. So the distance is given to you, you are giving initial, but you are not giving the final velocity. Then it means you should have an equation that will contain this. Okay, so let's see how we can derive the various equations so that we can see how things will work out for us. Okay. Now, let's assume we have a case of acceleration. Let's put time from here. So let's say from this side. If you want to make T the subject, is A is equal to V minus U over T. Once this side is fraction, we have said, once this side is fraction, let this side also be fraction. So just do cross multiplication, this times this times that. So we're going to have AT is equal to V minus U. So that T is equal to V minus U. We divide it by T over T. Okay. So we have found time for this. Okay, it means time is equal to this one. Now we can substitute this one into this equation. T for T. We can put this, we have, because T is equal to this, we can put this one in place of T. So let's see how that will go. So that S will then become 2 from here. S will become equal to what? U plus V over 2 times, let's put this one there, V minus U over A. So here there's no T. So if you are given an equation, maybe you have U, you have A, you have S, but you are not giving what T, and then maybe you have V. So let's see, we have in all we have how many variables? 1, 2, 3, 4. So we have 4 variables. You should have 3 of them. At least you should have about 3, or depending, sometimes 2. If you have about 3 of them, before you can find the other, you can ask to find the other. So the equation will be given to you, and then you have about 3, and then you can look for the other one. Okay, so in that sense, let's see. Once you get this equation, you can simplify it. If you are simplifying it, you are going to get S is equal to, is this one times this times that. It's because it's multiplication, top times top, down times down. Okay, so this is going to give us U plus V times V minus U over 2A. 2 times A is A. This is the same as what? 2AS is equal to U plus V minus U. Now 2AS can then become this distribution method, okay? And from your math, this will multiply that, and this will come multiply that. This will multiply that, this will come multiply that. So U times V is UV. U times minus U is going to be minus U squared. Now V is coming, V is plus, V times V is plus V squared. V times minus U is going to be minus UV. Okay? If you do rearrangement, you're going to get what? Let's group this one and that, because they are the same, you can group them. So we're going to get what? UV, this is coming, is minus UV, this is our minus U squared, this is our plus V squared. Okay, UV minus UV will give us Z. So that 2AS is equal to minus U squared plus V squared. This you can rewrite as S2 is equal to what? V squared minus U squared. Okay. Now you can rearrange and make U the subject, or V the subject, depending on whichever way you want to. Okay, so we can have what from here we can say n squared is equal to u squared plus 2as. So this is the third equation that we have. So here we have four of the variables, no t. So when we are not given t, we can use this equation. When we are not given t, we can use this equation. Alright, so all the equations that we are deriving, so this one equation 1, this equation 2, all the equations that we are deriving, you can use them to work. So what you do is that when the equation is given to you, you look for the equation that has all the variables that has the information, the variables here in the information given to you. Then you use that equation. So that is as much as possible. You look at the equation, get all the variables in the equation, see which equation contains all that variable, and use that equation. Now, as you practice for some time, you will easily recognize which one you have to use when the question comes. Right. So this is the third equation that I'm going to put here. So as for now, deriving equations becomes very easy because your maths, we have gone through the mathematics aspect plus 2a, this one, equation 3. Now let's see how we can get equation 4. Let's assume that one that will have t in it. Okay, that one that will have t in it. So the same thing here, we are going, starting with u, we are moving with a solution a, so that at the end, this a will change. The rate, there's a force that is pulling you F. As it's pulling you, your velocity will change to v, and that change is your acceleration a. This is your distance or displacement s. Okay, so we go in. Let's see. The first one we did, we substituted for t. Now let's get another equation here and see. Instead of substituting for t, let's assume that our initial velocity is u, but we are not giving v, so there's no v. Let's see how we can get make v the subject. So from here, if you are making v the subject, we're going to get what? V is equal to t will come and multiply a, so we're going to at, okay, and this is v. V is on that side, at. So it will actually be, let me make it let me write it first so that you can appreciate it. A is equal to v minus u over t. It is the same as v minus u over t is equal to a. Because we are interested in making v the subject. We want to make v the subject because we want to substitute for v in this equation. So basically we use these two equations to derive the others. Okay. So here we want to make v the subject. A is over 1. If you have a fraction, you try to get a fraction. So t will go and multiply this, and then 1 will multiply that. So we have v minus u is equal to at. Now when you have at, what happens? You want v, so all other numbers must cross the cross sign. So v is equal to at. It is minus here, so when it crosses, it will become plus u. So this is what we have. So we have this for v. We can substitute this into our second equation because we make it from this. Substitute it into the second equation. So s is equal to where v is, let's put v, this expression for v. So we're going to have u plus v. V is this now. A t plus u all over 2 times t. Right. So from this, let me clean this aspect. So we're going to have, let's simplify this equation. S is going to be equal to u plus u is going to be 2u plus at over 2 times t. Okay, now because it's times, we want to simplify this. Let's remove the fraction that we have. Let 2 come multiply this. It's times, so it's the same as this whole thing. So this whole fraction, this also go the whole fraction. So 2 multiplied this 1 times. So that's going to be 2s is equal to 2u plus 8t into bracket t. Now let's remove the bracket so that we are simplifying. So getting the bracket out. Okay. Let's simplify and then make u the subject. Like we made v the subject. Let's try and make u the subject here. Then we're going to have what? T will multiply out, T will multiply that. 2s is equal to 2ut plus what? 8t squared. Okay? Right. So let's see what happens. Now if we let's bring this one here, or this one come here. Then we're going to get 2s minus 8t squared is equal to 2ut. If we divide here by, we want u to be the subject, by 2t, we divide here by 2t, we divide here by 2t. Is that it? So that's we let me get it from this side so that we can have it. Right, so at this point, if we are making u the subject, of course it will be a little complex. So let's just, at this point, let's just consider to make s the subject, so that we conform to most of the equations. But if you try doing that too, you can still get back to an answer. Okay, it might have to be an expression for you. Most of the recognized equations in the textbooks that you'll be reading, we have this, that, and this. Okay, so let's see that for s. So we have an expression for a, expression for s, expression for v. But usually this is the parent formula. So let's say v, we have a, v. So let's see something for s. Okay, an equation for s. So we have an equation for this, we have that for velocity. So let's see something for s in that case. So we're going to have 2s here now. It means s is going to be 2ut over 2. We are dividing here by 2, so here by 2, here by 2. The other side 2, also by 2. So these two cancel that, and then s is equal to ut plus what? This is the same as saying half at squared. Okay. So if you are dealing with gravity equation and motion and gravity, then acceleration becomes u. So that becomes s is equal to acceleration due to gravity becomes, so a becomes acceleration due to gravity. S is equal to u t plus half gt squared. Okay. So in essence, we have these equations. We have 4 equations now. Right then. So now you should be very conversant with deriving